Oh!
The wrinkles, Alexa, the wrinkles.
I do not care.
The one thing in my closet that I'm making sure is not wrinkled is my prom stuff because Mother will actually come if it is.
Yeah.
The other thing that I was surprised to discover in this request list this year, oh no, son of a bean dip. There we go. Was there's only one like Selena song. And they actually didn't, like last year there was like 3 or 4 like Mexican songs, for lack of a better word, stupid descriptor, but you know what I mean.
You're thinking you're in a circle and you just like walk in a circle with the weird.
Yeah, cumbias, yes.
That's dumb.
You're dumb. Okay. But this year, there was only one that I've seen so far, and they requested Selena. They didn't request a song or anything by, but like, okay, I follow you. I got you. I'll hook you up. Line dances are good. We like line dances. Okay, what lesson are we on? What are we doing? Ellipses and circles, 7.2. We probably have pictures, right? No, we have a bunch of equations.
Well, we have 2 equations and
Ellipses.
pictures do not help me.
Okay. All right, ellipses, we haven't got circles yet, right? Right. Okay, so we did what, 2 through 12. Okay. Numbers 2 and 4 are pictures. 2 through 6 are pictures, so let me pull those up. But while I am pulling those up and turning the television on, number 8 is quantity x minus 4 squared over 16 plus quantity y plus 3 squared over 36 equals 1. Number 10 is quantity x plus 6 squared over 49 plus quantity x minus 3 squared over 100. Is that doing something? Don't. Yes, no, maybe? Yes. Number 12 is quantity x plus 8 squared over 25 plus quantity y minus 7 squared over 64 equals 1. Now, oh, did I turn it off? I must have turned it back off.
I don't know who had my book before me, but they must have like dunked it in a lake or something.
I'm sorry.
Every page is sticky and wrinkly.
That's crazy, bro.
Do you know the answer to that question?
What?
Probably know who had that book last.
I wouldn't know that. How would I know that?
Well, didn't you teach the people who had those books?
Probably. But how would I know which one's which?
Was it this year or last year?
I don't know, it was like, oh.
It just seems like you might remember somebody came into class with a dripping textbook.
I do not remember
Oh,
a dripping
yeah,
textbook.
Yeah, 2 book.
Come on, thing. Don't have all day.
It's the full shot. It's fun. You get to stab people.
To stab.
No.
They forge stuff. Forge and
It's a blacksmithing reality show.
It's really cool. I like it.
I like swords. Swords are cool.
You would enjoy the show, Garrett. It would be up your alley.
They smack the swords into things and bullets.
And some annoying guy comes out and says, "It will kill."
Doug is funny. How dare you?
It's annoying. It's decidedly annoying. Copy text from image. No, thank you. I don't want that. But that is. It actually works pretty well, actually.
Really?
Yep, it's pretty cool. Number 4 is this away.
Oh.
It looks like that. And number 6 is hello, what you do? Wait. Oh, I see what it did. Is that looks like this guy. So, what questions do you have before we talk about circles? 4, great.
We talked about circles. I was trying to teach a first grader what pi is yesterday.
What was that?
It's the ratio of circumference to diameter.
Well, he didn't know any of those words, so I had to explain step by piece and piece by step.
That's a nice ceiling shot.
Not so nice.
Not
Wow.
Wow, so rude. Number 4, 4x squared plus y squared.
For number C, or not for C, for the constant, I got the square root of 6,403.
Constant?
Minus
So C.
64
Oh, constant.
The constant.
minus
So it's
12
rate
y
of y.
plus 276 equals 0. So what should we do?
We should put them x's and y together and then do the gap thing.
Yeah. Completing the square. Minus 64x y squared minus 12y equals negative 276. Now what?
B over 2 squared.
We have to take the 4 out of the x's.
We do.
Oh, that's what.
4x squared minus 16x
Make my life so much easier.
plus y squared minus 12y. Excuse me. Then what do we do?
What goes in that chunk? And it's negative 4. No.
4.
I know what I was thinking.
I do too. Glad we're on the same page for once. And positive 64. So
Plus 6.
We have to
add 64 here.
add 64 times 4 on the other side.
Yes. And 64 times 4
Could you
is a whole.
explain to me why we're doing that?
Which part?
64 times 4. And not just adding 64. Okay, I understand. Why does that apply still though? Is this not?
Well, because we're adding 64 inside this parentheses, but to keep it balanced, you have to multiply over here.
256, by the way.
Yes, it is.
No, we subtracted all the one on the right, right? No.
No, if you were doing it on the same side, it would be the opposite sign.
Well, that's all my issues there.
256. And then we do this one. Negative 12 divided by 2 squared. Negative 6 squared is 36. So we're going to add 36 to both sides. And then we factor. So 4 times x, yeah, minus 8 quantity squared plus y minus 6 quantity squared equals something. 16. And then what do we do? Divide everything by 16. I agree. Yeah, because this has got to be a 1, right?
Yes.
And then the 4 and the 16.
Reduce. That's absolutely true. Great. Now,
That will do.
we need to go to, what does it say to do? Graph it? Yeah, great. So let's graph it.
Since the y has the bigger base, then that means it's vertical.
That's true. It is an up and down doomy flotchy.
Center. I did what you did in the video.
What I did in the video.
You put vertex when you meant to put center.
In class on Tuesday, is that what you're talking about?
Oh yeah.
Okay.
Class, but I was in the video, so.
Ah. You weren't here?
I had already left by that point, I'm pretty sure.
Oh, yeah, I forgot. You left. You didn't leave early, but you left. Yes. We go to 1, 2, 3, 4, 5, 6, 7, 8.
But isn't it negative?
No,
No.
because H is,
Equation.
yeah, yes. And you can think about it the same way we've always thought about it, inside the parentheses, opposite of what you'd expect, if you want to think about it that way. 1, 2, 3, 4, 5, 6. So its center is right here. And now we need all the vertices. So what do we need in order to find the vertices?
Oh yes, this is the part that I did not understand.
H plus or minus A and K, and then the H. K plus or minus B.
Yeah, this one plus or minus this one, right? And this one plus or minus this one, basically, is, so it's potentially more useful to just understand and try to remember, instead of trying to remember all the letters, to remember positionally. This one plus or minus this one, and this one plus or minus this one.
Okay, so how do you know plus or minus?
What do you mean plus or minus? No, he's both,
Oh,
right? Because we're graphing an ellipse, right? Right.
The vertices
But it's not actually quite what I said, right? Because A isn't 16 and B isn't 4. How do we get the A and the B? Because it's actually plus or minus A, plus or minus B, but it's not that number.
are square.
Yeah, so this one, his square root is 4, and this one, his square root is 2. Right? So we go 4 to the right and to the, no, 4 to the up and to the down of this one, right? Is basically what's happening, yes? So 1, 2, 3, 4, and then we put a dot.
And you always have to take the square root of the A.
Yes. Well, of the denominators, but yes. Because A is 2, and, well, A is 4 and B is 2, but, okay. And then go 1, 2, 3, 4, down here. What is that? That's 6? Yeah, so that's right. And then we go 2 in this direction, 1, 2, and 1, 2, and then we connect all the dots. I like to kind of do a little, it's easier to do on paper, but I like to kind of do little things and then be like, and then, and that little egg-looking shape is as close as yours needs to be.
That is the center, right?
The black is the center.
Yeah.
Yeah, and that little egg-looking shape is as good as yours needs to be. Great. There are ways, and actually, if you wanted to do this, and you're going out and you're like, okay, I want to make a wooden oval. You're a woodworker man, and you want to make a wooden oval. What you do, if you want to do it, and you want to do it a certain size, you put nails where the focus is, and then you do a string on that to the where you want to go, and then you just go, and it'll make an oval. Okay. Any other questions before we learn the easier circles? 8.
I didn't read directions on these ones.
What? You didn't read instructions? How dare you? Then yours was a lot easier. It's like, just put dots and then connect it. It's not much harder than that. They're not too bad. All right, so on number 8, we're supposed to write an equation for the ellipse with vertices at 4, 3 and 4, -9, yes. I'm struggling to draw 4, but you get the idea. And length of minor axis. Minor axis is 8.
Did you put x equals 8, or can you just put 8?
X equals 8 is a line.
Is the axis the same? Is the axis and symmetry and the axis are two different things, right? Yes.
Yeah, I mean, so yes and also no. This has 2 axes of symmetries. This one is the minor one. So this is the short side, is 8. And these are the vertices, not the co-vertices. So these are the long ones, right? True enough. So let's just kind of, you don't necessarily have to do a full picture, but it might be helpful to kind of get an idea of what's happening, right? So 4, 3 and 4, -9 right? So this is a vertical dude. And it has a minor axis of 8. So this length, this way, is 8. From here to here, right? So what do we need to know? We need to know the co-vertices, or we need to know, it would be helpful to know where the center is, right? So let's see if we can figure out the center.
The center of 3 and -9 is -3, right?
It is. So what is this point? 4, -3. So let's start building our equation based on where we are a little bit. All right. So in the parentheses is going to be x minus 4 and x plus 3, right? And we know it's going to equal 1. That's easy money. We just got to figure out what is in the bottom.
Is it y plus 3 or is it x plus 3? On the second.
Oh, it's y. Yes, that's what I meant.
The bottom would be, the bottom on the y one will be 6.
The bottom on the y one would be 6. I don't think so. I don't think that's accurate.
Oh no, it'd be 36. It'd be the square root, right?
Be squared, but is what you meant. But not, where are you getting 6 from? Because 6 is incorrect. But I think you're thinking in the right place. You're just doing the math different.
Plus or minus 6 to get to each of those vertices.
Oh yeah. Because it's yeah. No, you are thinking right. I'm thinking wrong. It's me, not you. Yeah. So to get to this guy, you go 6, and this guy you go -6. And so yeah, what's 6 squared? 36. So this is 36.
Should we do the same thing with?
Yeah, we do. So what would that be?
16.
It is 16. Because this is 4 plus or minus 4. 4 squared is 16. Good.
Clear as very dirty mud.
Does it make sense or does it not? Well, good. Then it's clearer than that. You're not confident in your ability to remember it yet, which means you should probably practice a few. Yes? Yes. Good. Good. But that's different than clear. Clear or not clear, right? Because if it makes sense, then we're on the right track. If it doesn't, we need to pause a second, right? Let's learn about circles. They're even easier.
Easier?
Yeah.
Still 7.2.
Yeah, we're gonna skip the middle of 7.2. We're gonna skip eccentricity, but we are gonna talk about circles. If you want to learn about eccentricity, you can do it on your own. You could even learn that I'm pretty sure it's actually pronounced eccentricity, but I could be lying. All right. Circles. Standard form for a circle looks like this one. X minus h quantity squared plus y minus k quantity squared equals r squared. What is the r? Radius. Now this, if we pause, I'm going to pause since this is pre-cal for us to use our brains. This is the same as an ellipse formula. What are A and B going to be on a circle? Equal, right? They're going to be the same. And so if we call this r squared and this r squared, we multiply both sides times r squared. 1 times r squared is r squared, right? So it's the same formula. It's just simplified because these are always going to be the same, right? And so that's what happens. So let's do an example. Let's write. Oh yeah, that's good. I like that. The instructions say write the equation in standard form and identify the related conic. We only know 3 conics. What are they so far? Parabola, ellipse, circle, right? Those are the only ones we know. So those are the only possible answers for that part, right? So we write it in standard form and say which one it is. Let's start with this one. Y squared minus 3x plus 6y plus 12 equals 0. This one, we don't even have to wait till the end to know what it is. What is it? It's a parabola. It's definitely a parabola. How do we know it's a parabola? Because there's only one thing squared, only the y squared. X, there's no x's squared, right? So now we need to write the thing in standard form. So what do we do?
To get them on each side of each other. You can separate the x and the y on each side.
Yeah. But the x is on one side, y is on the other side. Which one's the 12 going to go with?
The
X's.
and why is that?
Because that's the one that's not squared.
Okay.
Okay. Great. So we're going to have y squared plus 6y space equals 3x minus 12, right? Now what? Complete the square. 6 divided by 2 squared. 3 squared. 9. Plus 9. Plus 9. Right? And then we factor. Y plus 3 quantity squared equals 3x minus 3. Where does the p go? On the squared side or the not squared side?
Squared, not squared. It's on the squared side.
It's on the squared side. Actually, no, it's not. It's on the non-squared side. But we don't have it yet. No, yeah. It's not. It's on the not squared side. But we don't have a p yet. We're not quite in standard form. We're like close.
Non-squared.
You can factor a 3.
We can and should factor 3. Factor whatever is in front of the x out, yeah? y plus 3 squared equals 3 times x minus 1. There it is. It is a parabola. Great. Let's do another one. Garrett, you're getting your wish from last week, last class. You're like, could we do some more where we have to complete the square? Now we are.
Yay.
And the fun doesn't stop here because we have a whole nother conic to learn.
Ooh, what's it gonna be?
Yeah, a hyperbola,
Hyperbole.
which is like two parabolas.
Is it the
Okay, so, no, it is not related to the word hyperbole. that is totally different etymology. For y squared minus 24x plus 32y that was so close, but not quite right.
I don't know the Spanish alphabet. Well, I do, but I don't know what, like.
Okay, what should we do?
Get group them.
I would do totally something different first.
6 over first.
I want to, this is pre-cal, so I'm going to push you to see the easiest thing to start with. Divide everything by 4.
I'll divide it.
Yeah, that's a great first step. That'd just make our lives way easier, right? So then we end up with x squared plus y squared minus 6x plus 8y plus 9 equals 0. Now what should we do?
Now we can group them together.
Yes, complete the square and all the things, yes? X squared minus 6x space y squared plus 8y equals negative 9. Any predictions on what shape this is going to be?
No, an ellipse.
You can guess an ellipse and be right either way, but it might be an even more specific ellipse. It might be a circle. Okay, so let's do the first one. Negative 6 divided by 2 squared is negative 3 squared, which is 9. Add 9. Add 9. Oh, that's nice. Done. Killed it. Murdered. My brain somehow took the song Heartache on the Dance Floor and turned it into Murder on the Dance Floor. And I was about to start singing and I realized that's not actually the words to that song. It's not murder. There's no murder. It is definitely a circle. X minus 3 squared plus y plus 4 squared equals 16. There ain't nothing multiplied there. There ain't nothing multiplied there. He's a circle. We're finished. Because if we divided everything by 16, it would be 16 on the bottom of them. So it is a circle centered at 3, negative 4 with a radius of 4, right? And the last one, if you were to do guided practice 5C, you would discover that it is, in fact, an ellipse. Homework number 1. Here we are. That is the implication, yes. Page 438. Numbers 24 through 36 evens. Oh gosh, almost died. rotate, hyperbolas, rotations, parametric. Oh, yeah, I think that's right. I think that's exactly what we do. We do need to do so. Yeah, we've got 2 more lessons, and then we're going to take a test, which is great because it means we will definitely make it to Unit 8, which is good. That was where I wanted to make it at least 2.
We're gonna graph the circle?
Yeah, that's perfect. Okay, what?
Are we gonna graph a circle?
Are we going to graph a circle? No.
No?
Like if I was to graph that one that we just did, I would put a dot at the center. I would go up 4, 4, 4, 4, and
I see.
that's what I would do. In fact, what I would do, if you were graphing these, when y'all go to like graph these at home, what I would do is I would find you a circle, draw the circle first, and then put the axes on it. That's what I would do.
You know it's a circle when there's no
Yes, or you could use a compass. That's true. Compass would also work great. What?
there's no P, you know it's a circle.
When there's no any P on the left at all. If there's not anything in front of the parentheses on either one of them. Because if there was something in front of, like if there was something you had to factor out of one of them, then when you divided, the numbers would be different. But so if there's not, then it's a circle. Okay, no, that's next. Just kidding. Let's hyperbola.
It's a new lesson.
Yeah. Hyperbola is,
Oh, it's a new lesson there.
hyperbolas are parabolas that go like this or like this. And actually, believe it or not, oh no, that's not true. No, that's not true. I was about to lie. Well, no, I was not about to lie. Actually, I'm right. I am right. Every parabola is actually a hyperbola, eventually. Because the cones keep getting bigger and bigger and bigger. So there's not, in a purely theoretical world of mathematics, there is no such thing as a parabola. Every parabola is a hyperbola because eventually it's gonna cross the other side of the thing eventually. All right. So let's talk about hyperbolas. Let's get standard form of a hyperbola. Are you ready? If I can make it through this entire chart without making any mistakes, it might be a miracle. Are you using pencils? I hope so, because it hasn't happened yet. Let's see what goes. Standard form for a hyperbola. Horizontal one. So one opening like this, right? They would be the same on both sides. Not like that mess that I drew, but close enough. All right? It looks like this. X minus h, that part's right. H goes with x squared over a squared minus y minus k quantity squared over b squared equals 1.
It's just subtractive.
That's right. So you could argue, and I would in a way, that a hyperbola is an oval that's been ripped inside out.
That's what I was actually thinking. So.
That's exactly, that's what it is. Same idea as an ellipse, it's just turned inside out. Its center is going to be where? Yeah, that's easy money. We're starting to get the pattern, which is good. If we can get the pattern, then we're halfway there. It also has now, a hyperbola, unlike an ellipse, only has vertices. It doesn't have vertices and co-vertices, right? Only has vertices. Sorry, no, I didn't make a mistake. I kind of did a little bit, but only in what I said, not in what I wrote. Because there are parabolas. Because the squares are there or not there. So there theoretically are, but then they're also not. So I don't know. That's interesting. That's a higher level theoretical math than what I was thinking to think today. Vertices are, they're going to, now, where are they going to be? If this is opening that way, which one is going to stay the same, the H or the K? The K is going to stay the same, and the H is going to change. So it's going to be H plus or minus what? The A in this one goes with, C is not a bad guess, but C is not what hits this. C is there, but not in vertices. H plus or minus A. So the one underneath the X one, yeah? Right? K. The K is going to stay the same. We definitely have foci, I don't know. I'm pretty sure it's a soft C, but I could be lying. Where are they going to be?
The focuses, right?
They're these points, right? The ones where you bend it around and it hits that. They're the construction dots.
They're not the center, but.
No, the center is over here. Yeah.
H plus or minus B.
That's a good thought, but no, now is where we get the C. H plus or minus C, K. The K is going to stay the same, right? We're still on the same line. That makes sense. That's easy money. I'm going to have a new concept here that is the conjugate axis. So the fact that it is a axis means that it's going to be a what over here? A line. It's going to, so we're going to have an equation of a line, yeah? So the conjugate, what? It's a good thought, but no. It's 50-50 shot. Took a chance. Took a chance on me. Why don't you like it?
I just can't seem to get what numbers straight.
The conjugate axis, I didn't make a mistake, but I did do something that caused you to guess wrong. Because the book wisely lists not the conjugate axis first, but the transverse axis first, which makes more sense. Because the transverse axis is, in fact, the line y equals k.
Transverse axis.
Wow, that was pretty hick of you. Is y equals k. So the transverse, the one that is transversing the hyperbola, going across is the y one, right? The conjugate one is the one that if we were to rotate this around it, it would make a donut shape, right? Well, an expanding donut. Right?
I don't know, expand donut.
A torus wraps back around. So this is like a torus that has infinity on the outside.
So parabola.
No, so a paraboloid is a 3D parabola. Hyperboloid is the shape, what the shape is called. All right, we got a couple more things. Hyperbolas, unlike, now this is different, right? So parabolas, and this is why this is the why there are hyperbolas and parabolas, because if this part wasn't true, then hyperbola really is just a backwards parabola, which is not actually, because hyperbolas, unlike parabolas, have and it makes sense that they have because we've got denominators. Parabolas don't have anything divided, right? So hyperbolas have asymptotes. They have asymptotes that it's never going to cross, right? And that start from here and go up here. So the parabola actually goes, hyperbola, unlike a parabola, does have a point that we're going against. We don't just turn or something, right? So we need to be able to find the asymptotes. The asymptotes are going to be lines, which is nice because if you can get if you can dot in the lines, then you can draw the thing easier, right?
This is basically what just 3D printers do, just a ton of graphing their whole lives.
Yes, that is true. The asymptotes. Asymptotes are at y minus k equals plus or minus b over a times the quantity x minus h. That formula should look a little bit, just a hair, a bip, and a bob familiar.
Kind of resembles quadratic.
Well, so yes, kind of. That's not even the one. So this is not a quadratic because of the squared. So there's actually a linear one that it also resembles. It resembles point slope form of a line, which is something you probably haven't done in a long time. But point slope says y minus y1 equals m times x minus x1. So it's the same idea where the y-intercept are h and k, and the slope of the line is plus or minus b divided by a. We got the y-intercept being the same, and then the slopes are opposite each other, which makes sense. But not necessarily perpendicular, but they are opposite each other. And C we find the same way we've always found C. C equals the square root of a squared. Oh, except it's not quite the same, because of course it's not. Plus b squared. What is the formula for C when we're doing an ellipse? Yeah, on an ellipse, so for C it's the opposite sign of the middle one. For an ellipse it's minus. For a hyperbola, it's plus. So for a vertical one, what is the standard form going to be there?
But isn't that just Pythagorean theorem?
Yes. This one actually is. The other one is kind of opposite. But yes. And like I said before, they both come from very similar place as the Pythagorean theorem is derived from. They're both related. So vertical one is one that goes like these, yes? Except without all the dumbness. Where's the center gonna be? HK. That's easy money.
Is the equation just this?
Oh. What would the equation be?
X minus h squared over b squared minus y.
So close, but no. There's one thing that you're not changing, that you didn't change, that you should change. How about y minus k, quantity squared, over a squared, right? That part you got, minus x minus h, quantity squared, over b squared,
Oh, right.
equals 1.
Fraction, so it actually matters.
Right, that's exactly right. So it does actually matter because subtraction in the middle. Unlike an ellipse it doesn't matter really whether you put the x one first or the y one first, and the vertical and the horizontal, whatever, that doesn't really matter. But on a hyperbola it does because of where the minus goes. All right? So the vertices you could probably figure out are going to be where?
H, K plus or minus A.
H, and then, no, it's A. If we rewrite it this way, I mean, it's just the one under the Y, right? I mean, that's ultimately what you really need to think about it. Because if you're trying to memorize it with the letters, you're gonna get confused. Where are the focuses is? H and then K plus or minus C. The conjugate axis is going to be y equals k. The transverse axis is going to be x equals h. Asymptotes are the same. True enough. Oh, except they're not, of course, because why would they be the same? Yeah, no, that make, yeah. Well, we think about it the same way. And actually, when we write it, I'll pause and make sure we understand, like, visually from here what we're doing. But it's A over B instead of B over A. X minus H. So, for the slope part of our line, right? For the slope part of our line, did I say the y-intercept? I didn't mean the y-intercept. A point on our line, the center of our line. The slope of our line is going to be, so for these, it's going to be the one under, this is rise and this is run. But on this one, this is rise and this is run, right? Because the y goes with, the rise is the one that goes with y, and run is the one that goes with x. This is the slope of the line. So it's always the one with the y over the one with the x, because rise over run, right? Make sense? C is the same.
Nailed it.
Okay. Nailed it, more or less. When is this class over? In 6 minutes? Let's see what kind of little example we can pop out real quick. Give you a little bit of homework. Get us started. Seems like a great idea to me. Okay. Let's graph this hyperbola. Y squared over 5 minus, well, that's kind of an annoying hyperbola, but that's fine. Minus x squared over 3 equals 1. So how do we know that this is a hyperbola and not one of the other conics?
Because there's nothing multiplied by the, wait, no, that's not right. That's
Subtracting.
Because they're both squared and it's subtracting, right? The y squared is squared. The y is squared, the x is squared, and it's minus in the middle, right? This is a vertical one. That's true enough. Okay, so see if we can get some puzzle pieces. What puzzle pieces do we really need in order to graph the thing?
Center the vertices.
Center, vertices, and I would pull out the asymptotes. You don't really need the foci unless it asks for it. Okay, so how do we find the center? HK, so it is, where is our center? Yeah, it's at the origin. Great. Now how do I find the vertices?
Take minus a. The thing is, they're squared on the bottom and written like this, so it's square root of 5 and square root of 3, which sucks.
Yeah, that's what I was mumbling about a minute ago. Yeah, so it's actually, you're completely correct and completely correct, that this one would be the square root of 5, which in order to graph that, we need something. So what is square root of 5 approximately equal to? .23, so 2. What I would do on these, if they're like this, I would round to like the nearest half, basically. And if you round to the nearest whole number, you're not going to be like in a terrible way either. But I would round to like the nearest half. So what is the square root of 3?
1.77.
1.5.
Well, I hate to have to press like, yeah.
This is probably the first time in your math career that anybody has told you to round to the nearest half. Just think about it as whichever it's closest to, right? Okay. So, where are his vertices?
0, 2, 0, -2.
0, 2, 0. I'm going to say negative 1.5, but. Wait. No, I'm not. What am I saying? What am I doing?
I don't know why you're doing that. It's plus or minus.
Yeah, 0. I don't know what I'm doing. Yeah. I'm going to do what you said. It's a great idea. I agree. All right. Now what?
The asymptote. Do we want the asymptote, you said, right? So
Yeah, I think the asymptotes would be handy, right?
Y minus k equals plus or minus a over b times.
So y minus 2 equals, what would that be as a fraction? 20 15ths, so 4/3. 2 over 1.5, move the decimal over once, and then reduce it.
third portion. Does it say over b?
It's rise over run. So this one over this one. So it's the y over the x. The one that goes with the y over the one that goes with the x. That's why I'm saying if you think about it that way, it's going to be a lot easier to do. I wrote this. I've written something wrong on this line.
Why is there a -2?
Y is there -2? We're not doing any like vertex. It's the center, yeah? How about just y? Equals 4/3 x. Great. So then I would dot in the this plus or minus this.
So this is the asymptote?
Yep. This is the asymptote equation, so I would dot that in. So go up 1, 2, 3, 4, down 1, 2, 3, 4, over 1, 2, 3. So this dot, this one, dot in, asymptote, this one, dot in asymptote. I would then put dots at the vertices. So right here and right here. And then I would just kind of follow the asymptotes and end up with the dots. That is why dotting in the asymptotes is helpful, because then it's super easy to graph. And it looks like that. It's beautiful.
It's a vertical hyperbola.
Oh yeah, except it doesn't look like that. How about 0, 2 instead of 2, 0? It doesn't look like that. That would be if we flipped it all around. That would be that one. How about this one? We still do the same thing, right? I don't know what it is about this unit. Maybe it's because it's April. I keep making silly mistakes. So yeah, this is totally what I meant. Just testing you. Second homework. Yep, that's what I'm gonna do. Okay, page 449.
40?
Numbers 2 through 28 evens. Guten Bye.